right, class. Today we are in topic 8, equations and inequalities, block 4. We're going to be on page 247 in our workbook. And in this block, our goal is to analyze situations involving linear relationships and formulate linear equations and inequalities to solve problems. We're also going to apply properties of operations and strategies to add, subtract, factor, and expand linear expressions and understand how rewriting an expression can shed light on a problem situation. So, to get started today, we're going to watch a video that was created by mathantics.com. This guy's a very brilliant person, and basically, what he's going to do is he's going to break down the distributive property for us. So I want you to pay very close attention to our video, and then I'm going to have 3 questions based off of what we learned from the math antics guy.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to talk about a really important math concept called the distributive property. Well, at least that's what it's called sometimes. You may hear it referred to as the distributive law, or even the distributive property of multiplication over addition, by people who want to sound really technical. But no matter what it's called, the concept of the distributive property is the same. Before we actually dive into that concept, there are 2 quick things that will help make it easier to understand. The first is simply knowing what the word distribute means. To distribute something means to give it to each member of a group, like an old-fashioned paperboy delivering newspapers to each house in a neighborhood. One for you. One for you. Oh, sorry. One for you. And one for you. The second thing you need to know is the order of operations rules of arithmetic, which we cover in another video. So you might want to watch that if you're not familiar with those rules already. That's because the distributive property is actually a way of allowing us to change the order of operations we do in certain types of problems. To see what I mean, have a look at this simple arithmetic expression, 3 times the group 4 plus 6. We're going to simplify this expression in 2 different ways. The first way will just use the basic order of operations rules that you already know. But the second way, we use the distributive property. And if we do the arithmetic right, both ways will give us the same answer. So for the first way, our order of operations rules tell us that we need to do any operations inside of groups first. And since these parentheses form a group, we first need to add the 4 and 6, which gives us 10. Next, we can multiply that by 3, which gives us a final answer of 30. Now, let's use the distributive property. The distributive property allows us to change this expression into a different form. Instead of multiplying 3 by the whole group at once, we can distribute that factor of 3 and multiply it by each member of the group individually. That means we'll make a copy of the 3 times for each member of the group, the 4 and the 6. So after applying the distributive property, our expression looks like this: 3 times 4 plus 3 times 6. Because we distributed the multiplication to each member of the group isn't needed anymore, so the parentheses can go away. Now, we can continue to simplify this new form using our order of operations rules. Those rules tell us to do multiplication before addition. So 3 times 4 is 12, and 3 times 6 is 18. The last step is to add those 2 results together. 12 plus 18 equals 30. Well, look at that. We got the same answer in both cases, which means our original expressions are equivalent, even though they have different forms. In the first form, the factor 3 is being multiplied by the entire group all at once. So we needed to do the addition inside that group first. But in the second form, we use the distributive property to rearrange the expression so that the factor of 3 is multiplied by each member of the group individually instead of the whole group all at once. Distributing that factor made the group go away, so we didn't have to do the addition inside that group first. So the distributive property is basically a way of getting rid of a group that is being multiplied by a factor. If you distribute the factor to each member of the group, you'll get the same answer you would if you calculate what's in the group first and then multiply. And it works no matter how many members are in the group. Like in this problem, we have to multiply 4 by the group 1 plus 2 plus 3. Again, let's try simplifying this both ways. In the first way, we start by simplifying what's in the group. 1 plus 2 plus 3 equals 6. And then we multiply 4 times 6, which gives us 24. Now, let's use the distributive property. We distribute a factor of 4 to each member of the group, which makes the group go away and allows us to do those multiplications individually. 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. Finally, we add up those three individual answers. 4 plus 8 is 12, and 12 plus 12 is 24. See, the distributive property gave us another way to arrive at the same answer. It's like the distributive property is an alternate path that you can take to arrive at the same point.
Oh, but what are you doing here? I'm always here.
Okay, great. We have two ways to get to the same answer. But why do we need two different ways to do the same calculation? And it seemed like the distributive property way was even more complicated than the regular way. Why would we ever want to use it? That's a good question. And it's true. There are times when the distributive property way is harder, like in our first problem. It was easier to just go ahead and simplify the group first because it's easy to multiply 3 times 10 mentally. But there are also times when the distributive property way is easier, like in this case, 8 times the group 50 plus 3. If we decide to simplify the group first in this problem, we end up needing to multiply 8 times 53, which is not so easy to do mentally. But if we apply the distributive property instead, we can change the expression into 8 times 50 plus 8 times 3, and that's easier to do mentally. 8 times 50 is 400, and 8 times 3 is 24. So the answer is 424. Realizing that the distributive property can make some calculations easier to do mentally can come in really handy for certain basic multi-digit multiplication problems. That's because you can break up the multi-digit factor into a group sum, like expanded form, and then distribute the other factor to the members of that group. Sound confusing? Here's what I mean. Let's say you need to multiply 5 times 47. Well, you could just use the multi-digit multiplication procedure, or you could change this into a problem where the distributive property will make it a little easier to do. The key is to realize that you can replace the 47 with 40 plus 7. Then the problem becomes 5 times the group 40 plus 7. And the distributive property lets us change that into 5 times 40 plus 5 times 7. Those two multiplications are easy to do. 5 times 40 is 200, and 5 times 7 is 35. So our answer is 200 plus 35, or 235. Want to see another example? Let's apply that same idea to this multiplication problem. 3 times 127. But instead of 127, let's change that into the group 100 plus 20 plus 7. We need to multiply that by 3, and the distributive property lets us distribute that multiplication to each member of the group. 3 times 100 plus 3 times 20 plus 3 times 7. That helps because we can do those mentally. 3 times 100 is 300. 3 times 20 is 60. And 3 times 7 is 21. All that's left to do is add those three products up, which is not too hard to do mentally either. 300 plus 60 plus 21 gives us 381 as our final answer. Now, before we wrap up, there's one more important thing that you should know about the distributive property. You already know that the distributive property works when the members of a group are being added, but it works the same way for members of a group that are being subtracted, like in this problem, 7 times the group 10 minus 4. You could do this problem the typical way and simplify the group first. 10 minus 4 is 6, and then 7 times 6 gives us 42. Or you could use the distributive property. You distribute the 7 times to both members of the group to get 7 times 10 minus 7 times 4. 7 times 10 equals 70, and 7 times 4 is 28. And 70 minus 28 equals 42. Again, both ways are equivalent. So the distributive property works for groups of any size, and it works the same for group members that are being added or subtracted, even if there's a mixture of addition and subtraction in the group. But the distributive property doesn't work when the members of a group are being multiplied or divided. For example, if you have 5 times the group 2 times 3, you can't distribute a copy of the factor 5 to each member of the group without getting a completely different answer. And the same goes for division. If the members of a group are being divided, like 4 times the group 6 divided by 2, you will not get the right answer if you distribute the factor 4 to each member. That's why the technical name is the distributive property of multiplication over addition. You're distributing the multiplication over all of the members of a group that are being added. And the reason that it also works for subtraction is that subtraction is really just a negative form of addition, since subtraction and addition are inverse operations. All right, so the distributive property is a handy way to rearrange arithmetic expressions. It's like a tool that you can use in certain situations if you think it will make a particular calculation easier to do. And even if you don't end up using the distributive property a whole lot for arithmetic problems, it's still a really important math concept that will be even more useful when you get to algebra. Until then, be sure to practice what you've learned in this video by trying some of the exercise problems. Practice is the best way to make sure that you really understand. As always, thanks for watching Math Antics, and I'll see you next time.
So after watching that video, who in here can tell me what the distributive property is? What is the distributive property?
Where you get the number outside of the parentheses and multiply by each number in the parentheses.
Good. That's a great explanation or definition. So let's see what the actual definition says. It says if x, y, and z are any real numbers, then the distributive property of multiplication over addition shows one way to multiply the sum of y and z by x. So this is basically exactly what Satari just said. She said if you have a number outside of the parentheses, you're going to multiply it by the numbers that are inside of the parentheses. And that's 100% correct. All right, so based off of what we know, if we were to, I'm just going to write this down at the bottom of this page. If we were to write the expression 4 times 3 plus 5, how could we rewrite this using the distributive property? What would be equal to that using the distributive property? What's another way we could rewrite that?
Can it be 4 times 3 plus 4 times 5?
Yes, ma'am. You're 100% correct. Great job. Now let's talk about y. If we do 3 plus 5, we get 8. And if we do 4 times 8, what do we get?
32.
32. All right. If we do 4 times 3, we get
12.
And 4 times 5 is
30.
20. And what's 20 plus 12?
32.
So are these equivalent to each other?
Yes.
Yeah, they are. So that works perfect the way that it was described to us. All right, let's look at one more way. What if we had the expression 3 times w plus 3 times 8? How could this be rewritten using the distributive property? In other words, what could we factor out of both of these sets of parentheses? What is the same inside of both sets of parentheses? Nobody sees something that's exactly the same in both sets of parentheses?
They both have a multiplication sign.
They are both being multiplied. What numbers are in there that are the same?
33.
Correct. Since 3 is the same, what we're going to do is we're going to take that 3, and we're going to factor it out. So we're going to bring that out of here. Now, when we do that, we rewrite it as 3 times what's left.
8.
Yeah, there's 8 plus what letter?
W.
W. And that's how we would rewrite it using the distributive property. So today we're going to focus on using the distributive property throughout the lesson. All right. And we're going to start by looking at a new alien family. So we've looked at the Sabco and one other family. Let me see. The Crabcos and the Sabcos. And so what we're going to do is we're going to focus on looking at a new family that's in the video game, which is the Ultimate Invaders. So if you would, Miss Alora, would you read this for us, please, ma'am? At the top and bottom.
In the highest level of the video game, players face the ultimate invaders. Players can win the game if they understand how this space alien is growing. Play this animation to see these strategies and their associated algebraic rules, like the Crabcos and Sabcos. Each ultimate invader has the same kinds of body parts, but in different amounts. How are the ultimate invaders growing? What will ultimate invader number 5 look like?
All right. So I want you to think about that. I want y'all to find what is the same on these little ultimate invaders. And I want you to see what's changing, what's growing. So what's staying the same?
The number of legs.
Yeah, so they got the same legs on each side at the very bottom. I see.
The stomach area, like there's still 6 of them. Like where the eyes go,
Yeah.
there's like 6 of them.
All right.
On all 3 of them.
What about their thighs? Are their thighs the same also?
Yes.
Yeah. So that was good. That was great. So we got these are the same. We also know that those legs are the same for each one. So we know that the middle section of the body has how many parts? Isn't that 8?
Yes, sir.
All right. So we got 8 in the middle. And so it looks like the only thing that's changing is the number of eyeballs and the number of what? Or the length in the what?
Legs.
Yeah, the length in the legs. So that's how they're growing, the eyeballs and the length in the legs. So based off of what we got here, I want y'all to try to figure out what invader number 5 would look like. How many eyeballs would invader number 5 have on both sides?
5 or 6.
I don't know. Here he had 1 on each side. Here he had 2 on each side. Here he had 3 on each side. So what would invader number 5 have?
5.
Okay. Oh my. So we're supposed to be drawing this right now. So while y'all are drawing, I'm going to draw. And this is question 1 and 2 in our workbook. All right, so when his legs grew on each one of these, the first one had 1, second one had 2, the third one had 3. So how many should he have?
5.
All right. All right, so this is what my guy's looking like. How's y'all's look?
The same.
The same.
All right, so let's see if we got it right or wrong. How many parts does he have in all? We got 10 for the legs, 8 for the body, and then 10 eyeballs. So how many is that going to be in all for his body part?
28.
All right, so we got 28 body parts in all. Let's see if we got it right. All right, so looking at this, number one invader had how many body parts?
Ten.
Pretty close.
12.
It's 12. Good. How many does Ultimate Invader number 2 have?
14.
We sure? Doesn't he get 2 extra eyes and 2 extra leg lengths?
18.
So we're going to have 16, right? 4 plus 12 would be 16.
Yeah.
All right. Now the next one, they get 2 extra eyes and 2 extra links in their legs. So what would that be?
18.
20.
Who do y'all agree with? The 20 or the 18? What seems to be happening each time? It's growing by how much?
4.
By 4, because you get an extra eyeball on each side and you get an extra leg square on each side every time. So Ultimate Invader number 4 would be how many body parts?
24.
Perfect. And how many for Ultimate Invader number 5?
28.
28. That's great. Is that making sense to everybody?
Yes.
All right. So right now, take a second to make sure that you have the correct answers for your body parts on why in your question number 1 and number 2. If you don't have your little creature drawn the correct way, make sure he looks right. He's got a total of 28 parts. His body consists of 8. His legs are 5 squares long, and he has 5 eyeballs on each side. All right, looking at the next slide, you'll notice that it says, here's a way that we can think about the growth of the Ultimate Invaders. So if you would you please walk us through what's taking place here, Sophia?
Sir?
Would you walk us through what's happening here?
So every family member, like adds 4 body parts each time there's a new family member.
Perfect. And what stays the same?
The body.
Yeah, the body stays the same. So in each one of these cases, we're taking 4 and multiplying it by the family member. And then what do we add to it? What stays the same?
The body, so 8.
Yeah, good job. All right, so looking at this, our rule that we have here is that y equals 4 times x plus 8, and that represents the way of counting the growth. The 8 represents the body of the invader. That's highlighted in purple, and we know that all the invaders have a body value of 8. So with each new family member, 4 squares are added to the limbs, just like Sophia said. Vincent, I want you to take a look at what's happening here. Tell us what's going on. Vincent might need some help. It's all right. We got him. What's happening, Braden? Take a look at what's taking place here. What's happening? What are the i's multiplied by?
Did you call me?
Yep.
You said what are the i's multiplied?
Yep. What are the i's multiplied by?
One, two.
Correct. It's multiplied by the invader number. All right. And so you'll notice that whatever that invader number is, if you have that invader number and you add 1 to it, that's what we multiply the legs by. And it gives you how many legs that we have in all. Because we're going to multiply it by the number of squares that are on the side. We know that invader number 1 has 2 legs on one side, so 2 times 2 would be 4. Or I guess we should say squares, not legs. But then on the invader 2, he has 3 squares on one leg, so we multiply it by 2 because he has 2 legs, right? And then the same thing happens for invader 3 and so on. So looking at our rule, Braden, what is our rule? Let's help him out. What's the rule, class?
The rule y equals 2 times 2.
Pretty close. Y equals 2x plus 2 times what's inside the parentheses?
X. Is that a plus or?
Yep, a plus. X
Plus
plus 1. And then what do we do last?
Plus 6 represents the way of counting the growth.
Perfect. All right, let's look at this last way to do it. Brooklyn, I want you to go over this one. What's taking place here? We're trying to figure out how there's a piece of the invader that occurs 4 times. So pay close attention to the top right and top left corner and the bottom right and bottom left corner. All right, so looking at that, Brooklyn was supposed to tell us what's going on. Can anybody help her?
They're adding both sides?
Kind of, sort of. So we got the top on invader number 1, top right, was what? We had 1 eyeball plus 2, right? And then on the bottom, we had 1 leg plus 2, or 1 finger foot looking thing plus 2. All right. On Invader 2, we had 2 eyes plus 2 body. Same way with the legs, we had the legs was 2 plus 2. And then on Invader 3, we had 3 eyes plus 2 and 3 squares for leg length plus 2, right? So what's our rule going to be, Brooklyn?
Y equals 4
Times what?
times x plus 2.
Perfect. So that is our rule. Y equals 4 times x plus 2. So we're going to take this and we're just going to make sure that it's the same using each one of these if it would give you the same result. So look at each one of those and see if it gives you the same answer for your number of body parts. In all cases, do you get the same number of body parts? Like if you look at this and you go all the way across, do they all give you 12? This would be 4 plus 8. Does that equal 12?
Yes.
Yeah, this would be 2 plus 4 plus 6. Does that equal 12?
Yes, sir.
And then this is 4 times 3, which is
12.
all right. So it all works. Same's going to happen for this one, this one, this one, and this one. All right. So that means that each one of these rules will work for us to find the number of body parts or the invader number. So are the 3 algebraic rules equivalent to each other? Would they give you the same answer?
Yes.
Yes, they will. So they are equivalent. All right. If you would, Miss Khalees, would you read this for us? And we're going to make sure to focus on taking our definitions and writing them down in our workbook. We need to define expressions, equation, and like term. So if you would, Khalees, would you read this for us, please?
Which part?
All of it.
Each of the methods for accounting the growth of ultimate invaders is called an algebraic expression or simplifying expression. An algebraic expression contains terms. Terms can be numbers of variables or numbers and variables multiplied together. Consider the algebraic expression shown here: 6x plus 8 plus multiplied together, plus 2x. This expression has 3 terms: 6x, 8, and 2x. In the term 6x, 6 is the coefficient of the variable x. In the term 2x, 2 is the coefficient of the variable x. Like terms are terms that can contain the same variables raised to the same power. 6x and 2x are like terms. In this expression, b is a constant. If there is more than one constant in the expression, the constants are also like terms. Algebraic expressions do not include equal signs. When two algebraic expressions are related by an equal sign, an algebraic equation is formed. Here are some examples of algebraic expressions and algebraic equations.
All right, so looking at the example of the algebraic expressions and the examples of the algebraic equations, what do you notice about algebraic expressions compared to the equations? Look at it real close. What do you notice about the algebraic expressions compared to the algebraic equations? What do equations have that expressions do not?
They don't have an equal sign.
Thank you. They don't have equal signs. Good job. It was like somebody just kept pointing to that or something. Great job. All right. So they don't have equal signs. That is correct. So that's how we'll know the difference between creating an algebraic expression and creating an algebraic equation. Algebraic equations have what, class? Equal signs. Good. Okay, so we were supposed to get 3 definitions here. So the 3 definitions we were supposed to get was an algebraic expression, right?
Yes, sir.
All right, so we're going to click on my glossary. We'll put that in here. We'll make sure we write this down. Miss Angel?
An algebraic expression is a mathematical
phrase that can consist of numbers, variables in operation, or grouping symbols.
Great job. So I'm going to give you about 10 seconds to write that down. You need that. That's in your workbook. All right, everybody should have that. Now, our next one was like terms. Brendan, I want you to read what like terms are for us.
If two terms in an expression are the product of the same variables raised to the same powers, the terms are called like terms, and you can combine them to simplify an expression.
All right. So I'm going to give you about 10 seconds to grab that one down also. All right, if two terms in an expression are the product of the same variables raised to the same powers, the terms are called like terms, and you can combine them to simplify an expression. It's kind of like saying if you have two squares and a circle. Well, I can add a square to a square, but I can't add a square to a circle and it make more squares or it make more circles. All right. So, with that being said, like terms are terms that are the same and you can combine them to simplify an expression. I believe our last word was an equation. Natalia, read what an equation is.
An equation is a mathematical statement that expressions have the same value.
Right, an equation is a mathematical statement that two expressions have the same value. So that's saying that 2 plus 2 is equal to 1 plus 3. That would be an equation. All right. Or 1 plus 2 is equal to 3 would be an equation. So I'm going to give you a couple of seconds to get that written down as well. And then we'll move on. And this is question 6 and 7 in your workbook. So on question 6, you were writing down these definitions. And then on question 7, we're actually going to work on simplifying expressions by combining like terms. Remember, like terms are terms that are similar. And so I'm going to pull those up now. And so I want you to work on these. So for the next 2 minutes, I want you to work on simplifying the expression by combining the like terms. So I'm going to give you an example up here. If I had this, my like terms, what I would do is I would put just put you a shape on them that are the same. So I got 5b and b, those are like terms. And then I also have like terms in my 1 and 3. And so to combine those, you'll notice that it says to add. So I'm going to do 1 plus 3, and I get 4. And then I'm going to do b plus 5b, which is 6b. And this is as far as I can go because these are not like terms anymore. So my answer is 4 plus 6b. And so you're going to answer A through C exactly the same. Once again, I'm going to give you 2 minutes to do that. One more minute, guys. All right, so let's take a look at this. So looking at the first one, let's go ahead and see what Hagen came up with. Hagen, what'd you get for A?
For A, I got 10 plus 8x.
All right, and how'd you know that 3x plus 5x plus x would equal 8x's? I want you to count it real closely once again.
Hmm.
3x's plus 5x's is how much? You're right, it's 8x's.
8x's and then
Plus one more x would be?
plus x. Oh, that would be 9x's.
There you go.
So it would be 10 plus 9x.
Correct. That works perfect. All right, let's look at that next one. Hermione, can you help us with the next one? With B?
I was just gonna ask you if I can talk to you after class.
Yeah, that's fine. Just remember we're recording right now, so just make sure to ask me at the end. All right, so on B, Hermione, what'd you say?
I got stuck on that one.
You got stuck on it?
Yes, sir.
All right. Let's see if Tamarion can help you out. What is a like here? Let's do it the same way that I did mine. What's alike?
The Y's?
The Y's, correct. So we got 2y and negative 4y. So if I have 2y and I take away 4y, how many y's do I have? It won't be a positive number. How many would we have? If you had 2 y's and you take away 4.
0
Well, let's look at it.
or negative 2Y's?
There you go. That's what I'm looking for. So I was at 2 and I go back 4. 1, 2, 3, 4. So this would take me to negative 2. So we got negative 2y. Then we're going to combine what's left. So we got a plus 2 and a plus 4. So what's 4 plus 2?
6.
That's right. That's our answer. Negative 2y plus 6. All right. We got one more left. And so looking at this, what are we going to do, Miss Takiria? What's alike on this, Takiria? Let's help her out. What's alike here, class?
The 2 Y's.
The 2y is correct. So we got 3y minus 3y. And so what would that equal?
Y.
Well, if you have 3 y's and you take 3 away, do you have any anymore?
Oh, 0.
Yeah, it would be 0. All right. And so then we have 10 minus 8, which is what?
2.
And so what's 2 plus 0?
2.
So our answer is going to be what? 2. So I want you to make sure you get that written down in your word book. Does anybody have a question about how we solve those? What's the most important thing to remember here? We're combining what? The terms that are what to each other?
Like terms.
Like terms. Good job.
Alike.
That's right. Great. All right. So at this point, moving from question number 7, we're looking at questions 8, 9, and 10. And so these are actually located on your Agile Mind to go to each question. And so you start at page 3. And so if you would, go ahead and read that, Hagen.
You have used properties of operations when you have worked with real numbers and expressions. Check your understanding by completing this table. Fill in the table with equations that demonstrate the properties. You can choose the variables you use for your algebraic expression representations. When you are done, compare your examples with the one shown. Your examples will probably be different.
All right. So the first example is the additive identity property of 0. It says that 1 plus 0 equals 1. And the algebraic representation for that is a plus 0 equals a. So looking at that next one, that is the multiplicative identity property. And it says that any number times 1 equals that number. So give me an example of a number times 1 where it would equal that number.
5 times 1 equals 5.
Perfect. That's a perfect example. Good job. All right. The next one is the existence of additive inverses. That means that a number plus its opposite will equal 0. Can someone come up with an example for that? What's the opposite of 2?
-2.
So if we did 2 plus -2, what would that equal?
Wouldn't it equal 0?
That's right. Perfect. All right, looking at our next one, we have the existence of multiplicative inverses. So a multiplicative inverse is actually the reciprocal of a whole number. And so if we take the reciprocal of a whole number and multiply it, it will equal 1. So for instance, if we said 4 times 1/4, what is 1/4 of 4?
1.
It is 1, you're right. So here they took the example and said 10 times 1/10 would equal 1. Now we're going to take a look at the commutative property of addition. Commutative property just means that you can add in any order the same numbers and you'll get the same answer. So 7 plus 4 equals 4 plus 7, which is the same thing as saying A plus B is equal to B plus A. All right. Now our next problem is the commutative property of multiplication, which is 5 times 6 equals 6 times 5. So what do you think would be for our algebraic representation?
Wouldn't it be letters?
It would be a letter. It's going to be the A and the B, but what's going to happen to A times B? It'll be what?
Wouldn't it change to B plus A?
Not B plus A, but B times A. You're correct. Good job. All right. Now, the next one's talking about the associative property of addition. Now, associative property just means that you're grouping an area of numbers that makes it easier for you to add. So a lot of times people do this with like tens or fives, and they'll add their tens or fives first, and then they'll add what's left. So in this case, this is just going to show how you can use any grouping and still arrive at the same answer. So in other words, 9 plus 3 is 12, and 12 plus 5 is 17, and 9 plus 8 is also 17. All right. Now, the associative property of multiplication is basically the same thing. They're just saying that it doesn't matter how you group it. When you multiply these three numbers together, you're going to get the same answer. So 2 times 7 is 14, and then 14 times 3 will give you the same answer as 21 times 2, which is 42. It's easier for me to do the one on the right side than on the left because 14 times 3 just doesn't calculate for me mentally like it does on the right side. So that is the reason for the associative property of multiplication. So all that's going to happen is you'll notice that A times B is grouped in the first one and B times C is grouped in the next one. And then last is the distributive property of multiplication over addition. And so all that states is that A times a number, for instance, B plus C, would be A times B plus A times C. And so the same thing can happen whenever we are using the distributive property to rewrite problems like we did at the beginning of class. And we learned from the math antics guy. All right, now number 4 and number 5, I'm actually going to leave for you to do on your own. You're going to go through and do those and answer questions 9 and 10. And then I want you to also answer questions 11, 12, and 13 in your workbook. So before we are dismissed today, how could we use the equation 4x plus 8 for the ultimate invader guy earlier? How can we use this to figure out which family member has 48 body parts? What would you have to do? Remember that this was y equals 4 times x plus 8, and y stood for the body parts. So what could we put in for y, since I said there are 48 body parts?
$48.
Yeah. So we could write this as 48 equals 4 times x plus 8. We know that 4 times x is 4x, right? And so when we have this, how would I get 4x by itself so that I can solve for x here in a minute? What would make 4x be by itself? What would 8 have to become?
A negative?
Yeah, we're going to have to add -8 to it so that it becomes 0. But if we do it to one side, we got to do it to the
Other.
And so we're left with 40 equals 4 times x. Now, how do I undo times 4 so that I have x right there by itself? We do the opposite of 4 times x, which would be to divide by 4. Good job. And so when we do that, we would find out that x equals what?
8.
Think about it closely. What's 40 divided by 4? Say it again.
10.
10, because 4 times 10 is 40. All right, so this is actually going to conclude our lesson today. Remember, you need to get on My Agile Mind and do pages 4 and 5 and answer questions 9, 10, 11, 12, and 13 in your workbook. We will rejoin tomorrow, and I will see you then.